that we have to learn about in the probability-ish stuff. So if you look at the textbook, there's one more section, but it's on matrices. Now here's the thing. Matrices are not in the curriculum, so I don't teach them. Miss Pace, when she taught this course, used to teach them anyways. If you are going into anything math-related at all in university, you're going to need to know something about matrices. So it wouldn't be a bad idea for you to look at that section of the textbook to try some of the example questions to see if you can kind of get your mind around it so that next year you're not shocked by them. That's all. Okay, they're not difficult, but there's a procedure that you kind of need to know how to deal with them. Okay, so we talked about independent and dependent events. When we're talking about mutually exclusive and non-mutually exclusive, the difference between independent and dependent events and mutually exclusive and non-mutually exclusive is that in non-mutually exclusive ones, it may not affect all of it, but there's an overlap, right? So if we're looking at those Venn diagrams, there's going to be some kind of probability where both things could happen at the same time, whereas in mutually exclusive events, they cannot possibly, no part of them can occur at the same time. So you would then think about those events happening separate from each other versus that there's some kind of overlap. So if we're looking at, so let's do a definition, mutually exclusive. Cannot occur at the same time. Ugh. Let me see if I can make this a little smaller. Yes, Wednesday next week is early release. Yes, that's exciting. What's so exciting about it?
I get to go home. I don't actually get to go home.
I used to have a group of students that every early release day they would go bowling. It was just a thing they did. And I always thought it was so fun. I wanted to go bowling with them.
In Toronto, they have late starts.
Yeah,
I have a friend who goes to...
I worked at a private school that had late starts. It was fantastic.
I have a friend who goes to running meet, and she has late starts every Thursday morning.
Yeah.
So she gets an extra hour of sleep every Thursday.
See, it has to be a board-wide thing because otherwise the buses charge a fortune for it. So one school can't do it.
What time do bus drivers go?
I don't know. Probably the crack of stupid like me. What? I don't like waking up as early as I do. I wake up 4:30.
So that you could drive here?
Yeah, so I get up at 4:30. I take the dog for a walk. I have to get the kids' lunches organized. I put breakfast on the table for them and then I get my stuff packed and I'm out the door by 6:45 so I can get here on time. Yeah. But and somewhere in there I have to have a shower, obviously. But yeah, then my husband takes care of getting the kids on the bus and stuff. All right, so Terry attends a fundraiser with 15 t-shirts are being given away as door prizes. Door prize winners are given a shirt from a stock of 2 black shirts, 4 blue shirts, 9 white shirts. Terry really likes the black and the blue shirts, but is not too keen on the white ones. Assuming that Terry wins the first door prize, what is the probability that she will get a shirt that she likes? So if we say the probability of getting, she likes the blue shirts, a blue one. Let's say blue with an E on it. What is the probability of her getting a blue shirt? Yes, 4 out of 15. And what is the probability of her getting a black shirt? Can those two things happen at the same time? Is it possible for her to get a blue-black shirt?
Like
What?
to combine the blue and black.
No, but in that list, is there a possibility of getting a blue-black shirt? No. So, it's either one or the other, which means that what operation are we going to use to figure this out? Addition. Right? If that word or, if I'm using that word or, there should be like lights flashing in your head. You should like imagine me jumping up and down and saying, add it together! Okay? So 4 plus 2 would be, and again, what's nice about this is it's got the denominator's the same, so it makes it easy to add. If that was the case, if it wasn't the case, if the denominators weren't easy to add together, that would be a good situation for you to turn it into decimals. Yeah, 2 over 5. Okay, so if we're looking at this one, a card is randomly selected from a standard deck of 52 cards. So I have my 52 cards up there, which, if there are 4 of each card and 13 hearts, what is the probability that either a heart or a face card will be drawn? So, first of all, let's talk about just the hearts. What is the probability that you will get a heart if you were to draw one card from a deck?
So, 1/4.
1/4. Or 13 out of 52, which is 1/4. Again, because of the operations that are involved, it's sometimes nice at this point not to put it in lowest terms until the very end. Okay? So the probability of getting a face card, what is the probability of getting a face card? Jack, Queen, or King?
Well,
12 out of 52. Okay? So now what is the probability that you'll get a face card that is hearts? Not 4. 3 out of 52. A heart face. So back when we talked about Venn diagrams, we talked about this idea of the principle of inclusion and exclusion. So when you're figuring this out where there's overlap, because you can get a face heart or a heart face, you have to subtract that, right? That middle part. So you could draw a Venn diagram to figure it out. That's also an option. But then you're dealing with like subtracting fractions and then adding them together. So it is easier at this point to use a heart or face. You would say 13 over 52 plus 12 over 52, and then subtract 3 out of 52, which would be 22 out of 52. And now at this point, it's a good idea to put it into lowest terms, which would be 11. All right. So again, if this is the case, you would do the probability of A plus the probability of B, subtract the union of the two. Remember that little symbol for union? or intersection of the two. Intersection of A and B. All right. I should have tested you last unit more on Venn diagrams.
Will we retest it on Venn diagrams?
No. Maybe I should give you a quiz before the midterms just on Venn diagrams. I don't know. Probably not. I'll probably just put it on the final exam. And at that point, you guys won't care. Because you'll all be in university. And they'll be like, as long as you don't drop a ridiculous amount, you're good. Oh, I didn't put the definition of non-mutually exclusive. What is that?
They can occur at the same time.
Can occur at the same time, that's right. Okay, so this next question again is a non-mutually exclusive event here. And basically what it says is that the product can damage, if there's a volt spike, the probability of damaging the power supply is 0.2%. The probability of damaging the downstream components is 0.6%. But there is a probability of P and D happening at the same time of 0.1%. That's right. So the probability of P or D is equal to 0.2 plus 0.6 subtract 0.1, which is 0.7. And again, there used to be a time that I was super obsessed with writing statements at the end. Not super obsessed with that now. But you noticed on my test there's lots of other ways that I make you explain things to me. So therefore, there's a 0.7% chance that both the downstream components and the surge protector and the product's power supply will be damaged. Therefore, you will owe a ton of money to your computer fixing person.
Or buy your computer.
Yeah, you might want to buy a new computer at that point. It's true. All right.